What if the biggest bottleneck standing between SpaceX and a true Starship launch cadence was not the engines, the heat shield, or even the tower arms, but simply not having enough land? On February 21, 2026, Cameron County Commissioners approved SpaceX's request to annex an additional 7,100 acres around Starbase in South Texas. This single decision more than doubles the current footprint of the world's most ambitious rocket factory and clears the way for the massive production scale required to make Starship the reliable workhorse for lunar infrastructure and Mars tanker fleets. This is SpaceX's genius solution to Starbase growth limits, and it may be one of the most important strategic moves the company has made this year. To really understand why 7,100 acres changes everything, you need to understand what SpaceX is actually going to build on it. Every single facility they are planning has a direct, measurable impact on how many Starships can fly per year and how quickly they can turn one around after it lands. Let's start with the most fundamental facility, the Starship production lines themselves. Right now, SpaceX builds Starship upper stages and Super Heavy boosters in a series of large high bay buildings at the current Starbase site. It is essentially a single-thread process. One vehicle moves through the factory at a time. If you have ever watched a single checkout lane at a supermarket during rush hour, you already understand the problem. The issue with single-thread production is straightforward. If anything goes wrong, such as a supplier delay, a weld that needs rework, or an inspection hold, the entire line slows it down or stops. There is no buffer, there is no parallel path. Every delay cascades downstream and pushes back the launch schedule. What SpaceX wants to build on the new land is parallel production lines. Multiple Starship upper stages would be assembled simultaneously in separate high bay facilities. Multiple Super Heavy boosters would move through their own dedicated build sequence at the same time. A single production line might complete one Starship upper stage every few weeks. 2 parallel lines double that output. 3 lines triple it. The bottleneck shifts from speed to throughput, and throughput scales with space. This is the same logic that turned Tesla's early single-line factory into multiple gigafactories, producing millions of vehicles per year. SpaceX is applying that exact manufacturing philosophy to rockets. But here is where it gets interesting. Dedicated production lines require parallel support infrastructure. Dedicated areas for ring fabrication, separate quality control facilities, and staging areas large enough to hold multiple vehicles worth of components. You also need dedicated crane systems, tooling bays, and environmental enclosures for each line, so that work on one vehicle never blocks progress on another. The new acreage gives SpaceX room to lay out a production campus designed from the ground up for high-rate manufacturing. Not a repurposed shipyard, not a series of tents and improvised shelters. A purpose-built facility engineered specifically for building the largest and most powerful rocket in history at a pace no one has ever attempted. This is the foundation of everything else. Once a Starship or Super Heavy booster comes off the production line, it goes to a test stand. A static fire test tells engineers whether the engines are performing correctly, whether the propellant feed systems are working, whether the vehicle structure is handling the loads, and whether the avionics are behaving properly. It is the final exam before a vehicle is cleared to fly. For Super Heavy, this means lighting up 33 Raptor engines simultaneously and holding them at full thrust for several seconds. The acoustic energy alone is enough to shatter windows kilometers away. The test stand has to contain and redirect that energy safely, while hundreds of sensors record every detail of the burn. Right now, Starbase has a very limited number of test stands capable of supporting Super Heavy static fires. When a booster comes off the production line and needs to be tested, it has to wait for a stand to become available. The queue builds up fast. A booster that is structurally complete and ready to fire might sit idle for days or even weeks simply because the test infrastructure is occupied. The new land gives SpaceX room to build additional static fire stands. Multiple stands operating simultaneously means multiple vehicles being tested in parallel. The queue disappears. The cadence accelerates. Additional test stands also enable a different kind of testing philosophy. When test stand time is scarce, every firing has to count, so engineers tend to run longer, more cautious tests. When test stand time is abundant, SpaceX can run shorter, more targeted tests and move on quickly. The entire testing culture shifts from conservative to aggressive. And aggressive testing is how SpaceX has always moved faster than its competitors. Each Raptor engine also needs to be tested individually before integration into a vehicle. The new Starbase acreage provides room for additional engine test cells closer to the production facilities, reducing transport time and allowing even faster iteration on engine design. When you are building an engine that needs to be the most reliable and reusable liquid rocket engine ever made, the ability to test rapidly and cheaply is not a luxury. It is a requirement. Every test stand built on this new land is a direct multiplier on how many vehicles can be certified and cleared for flight per month. Now let's talk about the fuel. Starship runs on liquid methane and liquid oxygen. Both propellants have to be stored in cryogenic conditions, methane at around -162 degrees Celsius and oxygen at around -183 degrees Celsius. Maintaining those temperatures at industrial scale for large quantities continuously is a significant engineering challenge that most people never think about. A single Starship and Super Heavy stack requires approximately 4,600 tons of propellant for a full launch. To put that in perspective, that is roughly the weight of 50 fully loaded 18-wheel trucks. For NASA's Artemis lunar missions, the vehicle also needs to be refueled in orbit, which means multiple tanker Starships launching in rapid succession, each carrying hundreds of tons of propellant to fill up the lunar lander waiting above. To support even a modest launch cadence of one Starship per week, you need propellant storage capacity that can supply that rate continuously without interruption. The current Starbase propellant farm is not sized for that. Not even close. The new land gives SpaceX room to build a propellant infrastructure on a completely different scale. Larger storage tanks, more tanks running in parallel, dedicated pipelines running from storage to each launch pad independently, so that fueling operations on one pad never compete with fueling on another. The new acreage also provides room for experimental propellant production units using Sabatier synthesis, combining carbon dioxide and hydrogen to produce methane and water. This is not just a nice research project. This technology will eventually be used on Mars to produce rocket fuel from the Martian atmosphere. Testing it at scale on Earth, right next to the launch pads, gives SpaceX years of operational data before the first crew ever lands on Mars. The propellant infrastructure is the circulatory system of the entire launch operation. Without it, nothing moves. The new acreage solves that problem at the root. The most visible part of any rocket facility is the launch pad. The new Starbase land will eventually host additional launch and landing infrastructure that directly determines how many missions can fly per year. Currently, Starbase has one orbital launch mount. A single launch mount is a single thread system, just like the original production line. If the mount needs maintenance after a launch, if the flame deflector needs repairs, if the water deluge system needs servicing, nothing flies until that work is complete. One pad means one queue. With additional acreage, the company has room to build multiple launch mounts with their own dedicated Mechazilla-style catch towers and independent propellant feeds. Each mount operates as a self-contained launch system. If one mount is down for maintenance, the others keep flying, enabling true parallel operations. Landing infrastructure is equally important. Every Super Heavy booster that is caught by the tower arms needs to be inspected, refurbished, and restacked onto a new Starship upper stage. With multiple catch towers and dedicated refurbishment facilities, the refurbishment cycle becomes parallel rather than sequential, and the overall turnaround time drops dramatically. The goal SpaceX has articulated is a booster that can be caught, inspected, refueled, and relaunched within hours, not days, not weeks. That becomes achievable when you have the infrastructure to process multiple vehicles simultaneously rather than funneling everything through a single choke point. As Starbase scales from hundreds to thousands of employees, it also needs housing, transport, medical facilities, food services, and all the other support systems that allow a large workforce to function effectively in a remote coastal location where the nearest city is a long drive away. The new land gives SpaceX room to build dedicated workforce housing and support facilities on-site or immediately adjacent to the operational areas. This reduces commuting time, lowers attrition, and allows SpaceX to recruit talent that might otherwise refuse to relocate to such an isolated site. Now step back and look at all of these facilities together: the parallel production lines, the additional test stands, the scaled propellant infrastructure, the multiple launch and landing mounts, the workforce support systems, and you begin to see what SpaceX is actually building. Not a rocket factory, a launch ecosystem. The system as a whole is capable of far more than the sum of its parts, but only if every part is scaled to match. A factory that produces 10 vehicles a month is useless without 10 test stands to certify them, 10 pads worth of propellant to fuel them, and enough launch mounts to send them skyward. The expansion of 7,100 acres gives SpaceX the physical room to eliminate the remaining bottlenecks and bring every element of the system into balance. That cadence matters enormously for NASA's Artemis program. Starship is the human landing system selected to return astronauts to the lunar surface. Every delay in Starship production and testing is a delay in getting boots on the moon. The new infrastructure at Starbase will help deliver the hardware on time and give NASA the reliable flight rate it needs to sustain a permanent lunar presence. Looking even further ahead, to the Mars missions that represent SpaceX's ultimate goal, the numbers are even more demanding. A Mars transfer window opens roughly every 26 months. When it does, SpaceX wants to launch dozens, possibly hundreds of Starships in a matter of weeks. The infrastructure being laid out on these 7,100 new acres is the foundation of the machine that makes that possible. SpaceX has once again shown that when the bottleneck is physical reality, the solution is to change the reality itself. By securing 7,100 more acres around Starbase, the company has removed the last major physical constraint on Starship's ambition. The production lines are coming. The test stands are coming. The propellant farms, the launch mounts, the catch towers, all of it is coming. And when it arrives, Starbase will look like the most important piece of infrastructure in human history. The land is ready. The factories are coming. And the question is no longer whether Starship gets to Mars. It is whether the rest of the world is ready for what happens when it does. What do you think? Is Starbase quietly becoming something history has never actually seen before? Drop your answer in the comments below.